Hello, Math 133 students. In this video, I'm going to give you some hints and help with Chapter 4, Project 2, where we're going to examine how arm length and height are related. Now remember, you've already submitted your arm length, your forearm length and height to your instructor. That should have already been done. So that means that we're ready to go with the project. So for my students, they submitted a week or so before we're talking about the project. So that way we have plenty of time. All right, so we're going to open the Google document at this link. Now, the forearm data should be available by the time you're watching this. I'm making this in fall 24. It'll change from semester to semester, so just kind of look for the link to be active here. Or so I'm going to click on the document, and here we have it. So this activity uses that arm length and height data that we collected from our class. So technically it was the forearm length and height data that we collected from our class. And I will have made the instructor, your instructor will have made the data set available to you, and I will make it available to my students once we have it collected. Okay, so as per usual, we're in Google Documents. We're logged into our Google account in Chrome. So we're going to click File and Make a Copy. So File, Make a Copy. And as per usual, it would be nice to have your name in the file name somewhere, either at the end or at the beginning. Put it someplace so that way it makes it easier for your instructor to figure out who is submitting what. It can still be calculated other ways, but that's easier. Speaking of which, you're also going to put your name on it. So your name is going to go right here. So it's not like you're going to hide who you are, but it's nice to have it up here in the file name for the instructor. Okay. So we're going to access our data with StatCrunch. So for me right now, as I'm making this video, I'm going to use an old data set. I'm going to use the data set from fall of 23, and that means all my answers are wrong. Nothing that I find will be what you find in the particular semester you're watching this video, and because the data I'm using are old. So just keep that in mind. So you can't copy what I'm doing because what I'm doing will not work for you, but I'm going to give you the flair of it. All right, so we're going to create a scatter diagram of the paired data using arm length as the explanatory variable. Okay, so scatter diagram is under graph. Sorry, scatter diagram, scatter plot. There it is. I wish they would put these in alphabetical order, but they didn't. So scatter plot's in the middle, scatter plot. So you click there. Your X is your independent variable, your explanatory variable. So that's your arm length. Your height is your Y. And then you say compute, and you have a graph. And again, my graph is not correct, so don't worry about it, right? You're going to find your own graph. You'll copy, right-click and copy the image. You'll go back and you'll paste the image. And there you have it, done. Now, part 2, judging just from the scatter diagram, what type of linear relationship appears to exist between the data? Do you think it's strong positive, strong negative, moderate negative? What do you think? Explain why you think so. So you're just going to look at your scatter plot and say what you think. And it's totally okay if you're not correct or if you are correct. Now, we went over in the notes what pictures look like, right? So strong negative, moderate positive, right? Perfect positive. I'll give you a hint, it won't be perfect, right? And we had this example here, strong negative, strong positive, right? So you have a kind of sense of what things should look like. So you use that and just your judgment and say, oh, I think it's this. And just explain why. That's all. It's okay if you're right, or it's okay if you're wrong. It's no big deal. It's just you explaining what you're thinking. I'll give you a hint, you should be looking at the graph. So that's why. So you're looking at the scatter diagram and making a judgment. Okay, now using StatCrunch, conduct a simple linear regression on our data set, gathering both the output and the scatter diagram with the regression equation drawn. Okay, so let's go back, close this. I don't need this picture anymore, so I'm going to close that. I'm going to go to Stat, Regression, Simple Linear. Right, the same place we go throughout this chapter to get anything. So stat regression, simple linear. Again, my X is my arm length, my Y is my height. And then I think it wants a graph right here. Graph, fitted line plot. That's perfect. So all we had to do is put the X and the Y in and say compute. So now there's 2 pages worth of info here. That's why there are these little arrows in the bottom right corner, because this is 1 page and then the second page is over here. So on the first page, you want the simple linear regression results. You want this piece up at the top. That's all you want. So you highlight just that section, Control C or Command C on a Mac, and down here paste, Control V. Only the simple linear regression results. Do not get the other tables. Those are chapter 14 tables, right? And actually chapter 13 is this part, chapter 14 is this part. Either way, you don't know what it is, so don't worry about it. So just get this part at the top. Then hit the arrow and get the picture. Options, copy, copy the image, go in here and paste that image. And there you have it. So you have your outputs and you have your picture. Okay, state the value of the linear correlation coefficient. And you can just paste it from your StatCrunch output. It's up here. So you can do that either from here, there it is right there, the correlation coefficient, or you can go back to your regression output, go to the first page, and just highlight the part you need. Right, so there's the correlation coefficient. So you can Control C, copy just that piece of it, and go down here and paste that piece of it. Done. That's all you need to do. Right, so does the value from number 4 support or contradict the strength? So you made a judgment about what strength you thought it was for number 2. Did you think it was, weak negative or whatever? So then look at that correlation coefficient. Does it support or contradict what you thought? And that is going to be, for some of you, support, and for some of you, contradict, right? So you'll look in your table, or I guess on your line graph, and figure out where your R value is. And then you'll say, oh, I thought it was going to be this, but it was actually this. Or, nope, I was totally right. I thought it was going to be, strong positive, and it was strong positive. Or I thought it would be, this, and it was that. So it could be a yes, or it could be a no. It could be a support, or it could be a contradict. So just say, support because blah, 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 right? Or it's totally fine if it contradicts you. Like, I thought it was going to be this, and it was that. So, but explain why. All right. Next, state the value of the coefficient of determination. Okay, so the coefficient of determination is your R squared value. So that's a copy paste thing. So you go up here, R squared, right? RSQ, copy, and go back in here and paste. Then interpret the value. Okay, well, interpreting the coefficient of determination is in section 4.3. There's a script for it. There's also a script for it right here. The formal interpretation of the coefficient of determination. It's right there. So there's your script. So use it, right? Follow that script and use it. So I'm just going to say use script, right? It's from section 4.3 if you want to know. But it's also on your exam notes packet. All right, state the equation of the least squares regression line. Well, you don't have to do the y equals. So it's right here. There's the equation. Now, I have had some students really struggle. They don't really like the whole arm length, which is x, and height, which is y. Like, they don't like that it looks like that. So let me just show you something real quick. If you go up here and you change arm length to x and height to y, and then you click options, refresh, poof, there it is. And it looks more like an equation. It's got a y and it's got an x, just like you expect. So if you like that, you can do that. So you can paste that output. Or if you're okay with the arm length and height, arm length, height, then options, refresh. Let me do this again. It would be this, right? So it's one or the other. So paste this or paste this, whichever makes you more comfortable. And it doesn't like that I made arm length one word, but I did. So we're just going to have to deal. All right, now you're going to interpret the value of the slope. That's a script, right? So we've run into that script many times. You're going to use the script to interpret the slope of that line. So you should know when you look at this which number of those numbers is the slope, and you should know how to interpret it. Then you're going to interpret the y-intercept. Well, actually, you're going to explain why the y-intercept does not make sense. So, because it doesn't. So, um, you could kind of run this either way. So, explain either explain the y-intercept or explain why you think it doesn't make sense. You could probably make it work either direction. So you should know when you look up which number is the y-intercept, and you should know how to interpret that or explain why it's not reasonable for this particular data set. So I'm not going to say any more than that. What value did you give as your forearm length? Okay, so now for this, when you submitted your project data, it emailed you automatically from the email you submitted what your forearm length was. Otherwise, you can ask your instructor what your forearm length was. So it'll be something in the 20s for almost all people. So I got to close that one. That was a previous project. So as you can see, most people are in the 20s. It does occasionally happen, usually for very tall people, that they're in the 30s, but most people are in the 20s. So you're most likely in the 20s. So you'll type in your value here for your arm length, and then you're going to use the regression equation, this regression equation right here, or this one right here, same thing, to find what the model thinks would be your height. I know it says show work, but there's not a ton of work to show other than to show the line with your value submitted. So I do want a little bit of work, but it's very, very minimal. So you're going to include your units and give me what you think your height should be. Then you're going to calculate your residual. Now the residual, there's a formula for it right here at the bottom of the page. It's your actual real life height, in this case, minus the one we just predicted. So you're going to take what you really are in height and subtract. So C formula, it's technically from section 4.2, but it's also on that formula sheet that we get to use on the exam. It's right here at the bottom. There it is. So your error equals, because that's what residual is. It's your error. It's how off you are. So the line makes a prediction for how tall you are, and you get to figure out how wrong it is, right? So this is how tall you really are minus how tall it thought you were going to be. Don't forget to include your units and give 3 decimal places. And then answer the questions. Were you taller or shorter than was predicted? And explain, right? So look at your residual. What happened? All right, last but not least, we're going to talk about Andre the Giant. Now, Andre the Giant was a very, very tall wrestler. He was 7 feet 4 inches tall. He was a very large person, and he was from France, actually, originally. He is in the very famous movie, The Princess Bride, which I would highly recommend. He was 223.5 centimeters tall. So that's his height. So now you're going to use that height, and you're going to substitute it into your equation here, but you're going to put it in for the height value, and you're going to solve for his arm length. You're going to figure out how long you think his arm is going to be. So that's what you're doing for this problem. It's a little tricky to show work, but you can manage it. You know, just show a little bit. Show the beginning maybe and show the end, and make sure you include your units, right? And then explain why he is outside the scope of the model. In other words, look at Andre the Giant and then look at our data set. Look at where we are. His height was 223, right? And his arm length will be substantial also. So your job is to figure out why that is far away. In other words, why is he an outlier, right? That's outside the scope of the model, is a person that's an outlier. So just talk about why that is. And then you're done. Then you're going to click Share. You're going to change it so that anyone with the link is a viewer. You'll copy that link. You'll go in here. Oops, not in there. Here. Sorry, I was in a different one. And then I'm going to view as a student. And then I'll click the web URL. And I'll paste my URL right here. And I will click Submit. And again, if you want to, you could save this as a PDF or download it as a PDF and upload the PDF. That's another option as well. So upload as a PDF. So whichever way you want to do it, web URL or PDF, you click Submit. Huzzah! We have confetti. So we know we've done it and everything is grand.